Bueno, nuevamente, muy buenos días a todos. Les agradecemos el tiempo que se dan para conectarse a estos webinars. Esperemos que les sean de gran utilidad. El día de hoy tenemos un webinar muy interesante, patrocinado por la compañía RODAJ. Me gustaría comenzar este webinar cediéndole la palabra a Eric Gama, quien va a ser quien nos va a apoyar presentando al ponente, y posterior a ello vamos a comenzar con el webinar. Si tienen alguna pregunta, les recordamos que la pueden ir formulando por medio del chat durante la plática, y al final vamos a estar respondiendo cada una de las preguntas. Puede ser formulada en inglés, puede ser formulada en español, no hay ningún problema. Al final vamos a estar resolviendo estas preguntas. Eric, por favor, adelante. Eric, adelante, ¿puedes apoyarnos con la presentación de George?
Okay, are you ready for me to start?
Just a few seconds, George.
Okay.
Hola, ¿qué tal a todos? ¿Me escuchan bien? Creo que sí, ¿verdad? ¿Me escuchan?
Sí te escuchamos. Sí te escuchamos bien.
Perfecto. Pues antes que nada, muchas gracias por acompañarnos en este webinar. Para los que no nos conocen, pues somos RODAJ, una empresa totalmente mexicana, con más de 24 años ya en el mercado, comercializando y distribuyendo productos químicos. Estamos enfocados en toda la industria en general, pero principalmente en recubrimientos y plásticos. Y ahorita en esta ocasión, pues les traemos un webinar de nuestra representada Chaytech, la cual está enfocada en la investigación y desarrollo de aplicaciones químicas para industrias, para todas las industrias, tales como para fotoiniciadores, estabilizadores UV, antioxidantes, y ahorita nos vamos a enfocar mucho en lo que son los estabilizadores UV. Estamos contando ahorita con la presencia del Dr. Mauer, va a ser el ponente en esta ocasión. Él tiene un Senior Scientist, pues tiene más de 36 años de experiencia en la industria química. Él fue egresado como químico del Bates College, también tiene un doctorado en química orgánica en Dartmouth College. Ha trabajado en empresas como PPG, en prácticamente todas las tecnologías, base agua, base solvente, base polvo. Se ha enfocado mucho en lo que es OEM y llegó a ser el director global para lo que es la tecnología de aspersión. Además, él cuenta con más de 12 patentes con las que ha contribuido en Estados Unidos. Entonces, pues ahí es la carrera de nuestro ponente el día de hoy. Pues mira, vamos a dar inicio a este webinar. Pueden escribir sus dudas en el chat en cualquier momento. Nosotros vamos a estar pues, tomando nota y al final vamos a tener unos 10-15 minutos para preguntarnos. Nosotros no se preocupen, nosotros vamos a hacer la traducción de las preguntas hacia George o hacia ustedes. Si quieren ir directo también no hay ningún problema. Pues en todo momento ahí, pues adelante, ¿no? Y disfrútenlo. George, we are ready to start, please. The floor is all yours.
Okay, let me switch over. See if I can get this. Okay, can you see my screen okay? Okay. If everybody can see the screen well, then I will start.
¿Ustedes la ven?
No logramos ver.
No se ve.
Aún no logramos verla.
Can you see my screen?
No, not yet.
No, George, we cannot see your screen.
That's not good. Let me
I can't.
see if I can figure this out. I will come back here.
Yes.
Yeah.
Yes.
Now we are ready, George.
Okay, so ready?
Yeah, please.
Okay, good. Today, we're going to talk a little bit about new things in UVA and HALs for protection of coatings. And we're really focusing on exterior applications, which of course is where most of the UVA and HALs are used. A little bit on wood, some that would be more automotive or aerospace, although some of this science can extend to other industrial applications. We're going to do some waterborne discussions where we've got some advanced technologies that give us longer life than some of the older technologies and much easier to use material, which for the laboratories and then for the manufacturing people, they will like that too. And then we've got a reactable UV absorber, which is a pretty exciting material. It's called the R455. And that has hydroxyls that reacts into a film so that it cannot migrate out. So for those applications where you want long-term protection, that's a really good option that is now available. There's also another specialty product that we've got, which is very good for wood coatings. It's a blend that will give you a little better color retention over exterior wood, whether it's doors or some stained piece of wood, maybe even marine applications. So that's a good material to talk about as well. We're going to go over some of the science behind it and the evolution of the waterborne UV stabilizers. Back in the 80s, Ciba-Geigy came up with a material Tinuven 1130, which is a water miscible UV absorber. It's also sometimes used in solvent-borne coatings, although I don't generally recommend that as the best option. You just pour it in. Sometimes you need to use co-solvents to get it into the water. We'll see a little later on that has a little bit of a problem because since it likes water, that means it can wash out of your film. So that's the old technology, 1130. Chitec also has that product. We call it 5530, ChiGuard 5530. And for some applications, it's okay. Doesn't give you long-term performance, but it can be okay. Then there were some dispersed UV stabilizers that came out in the 1990s. They were not benzotriazoles or triazines, so they had a limited UV visible spectrum and they weren't particularly permanent. So it was something different, but probably not even better than the 1130. That was the first try of something that would go beyond 1130. And then around 2005, there were some hard shell materials that came out, which were benzotriazoles, but it brought in a lot of emulsifier, a lot of carrier material, and they weren't necessarily easy to incorporate into the paint or stay stable in the paint. So there were compromises there, although clearly the material had a little better performance than the earlier dispersed stabilizers. And then around 2015, Chitec came up with a what we call a soft shell UV stabilizer, which is taking a well-known benzotriazole and figured out how to emulsify it in a highly concentrated form. So it just brings in a little bit of emulsifier, and it has been really working quite well. It's extremely compatible. It's stable within the coatings, and we'll show you a little bit more about that now. We have three different materials that have been emulsified in these highly concentrated forms. One of the materials is 5582 WB. The WB stands for waterborne. And basically, this is the same as our solvent-borne 5582 benzotriazole. And this is the benzotriazole entity up here. Very good broad spectrum UV absorber, fairly permanent. It's not as permanent as a triazine, but it's pretty good, and it's better than 1130. It forms a nice white milky emulsion, very easy to incorporate into your film. The other UV absorber is a triazine. It's ChiGuard 5400. It's really the same molecule as our ChiGuard 5400 without the WB, just emulsified in a concentrate. The same molecule that Ciba-Geigy used to sell is Tinuven 400. It's extremely permanent material. Some of it reacts into your film or grafts in with this hydroxyl. It's a big molecule, so it's minimum amount of migration. The only bad thing about the 5400 is its UV spectrum is not as broad. So if you need to protect out around 370 nanometers, it doesn't give you quite as much protection. So it's actually a good idea, and I'm going to jump ahead to a question that everybody always asks if I don't discuss it. Mixing these two is a very good idea. This is extremely permanent and covers the high energy part of the UV spectrum very well. And this is a little less permanent, but has a broader spectrum. So they work very well together. The ChiGuard 101 WB is a hinterdimming light stabilizer. It will take care of the radicals that are formed, and it is non-basic, so it won't interfere with a cure if it's an acid catalyzed cure or something like that. It's also a nice emulsion. All three of these are very nice emulsions that can just be added in, 1, 2, or 3 of them. Actually, some customers do 1 to 1 to 1, which is actually a pretty smart 1% of solids on solids of each of these is an excellent starting point. Gives you outstanding performance. This is just a demonstration of how easy it is to formulate with these materials. You don't need to bring in co-solvent. You don't need to make a pre-emulsion or a pre-dispersion or have some fancy processing step. You just add them and they work. So Chi-Tech has worked out those details so that it's not just user-friendly for the lab people, like in this demonstration, but also very user-friendly for the manufacturing guys. So they can make it quickly and easily without the cost of intermediates. Okay, we said soft shell, and the soft shell is actually very good in that you can see the particle sizes here are extremely consistent. They're very stable. There's no big particles that will kick out and form a sludge or goo or something like that. Extremely tight particle size distribution. So a really good material. Here's some performance, and I'll start off by saying that this test does not involve exterior testing or exposure. This testing is really just done on a QUV. It's the 340 bulb, which simulates sunlight pretty accurately up through about 350, 360 nanometers. It's very, very good at reproducing sunlight. Isn't quite as good out towards 400, but it's a good test. And you can see how the 1130 over time, here it is a color test. The color's changing more with the 1130. And here's the gloss retention. And you can see after about 4,000 hours, the 1130 starts to be weak. And the reason the 1130 is weak is it goes away. And there's several reasons why it can go away. It has an ether-ester linkage on the outside, which is not very stable. And it's already water compatible, so it can wash out. Now, this test didn't have a rain part of the test, so it's a little bit easier test. And we'll see later on that you don't have to go to 8,000 hours in order to see a really big difference if you incorporate some exterior type exposure problems. And that would be something like rain, or actually in the automotive industry. For those of you that happen to work in that, you'll know that there's all kinds of different materials and things that come into play. Gasoline can hit your coating, or windshield washer fluid. We found car wash soaps can even take some of the UV absorber out of the film if it's not tied down well. So this testing is actually mild compared to what goes on in the field. This is the 1130 molecule, that old one. Originally, Ciba-Geigy came up with it back in the 80s. ChiGuard makes it. We sell a version also, 5530. And for those of you that are using it, I don't want to say it doesn't work at all. It just isn't high performance, long-term UV absorber because it does go away. This segment in here, which is 6 to 7 units of ether. So these are ethylene oxides that have been extended off of the benzotriazole. That's susceptible to oxidation and cleavage. And we think that's one of the reasons why the 5530 or the 1130 isn't performing well when you go out into the, say, 3 to 10 year period, especially 5 to 10 years, it's not helping you. Okay, one of the things that we always found curious was 1130 in a weatherometer or in a QUV seemed okay. It was never the best, but it was usually pretty decent and certainly much better than a blank that had no UV absorber. But out in the field, whether it's in Florida or Taiwan, where Chi-Tech is based, is Taiwan, they have harsh environment there. Or Okinawa is a common test site for the Japanese auto manufacturers, or Australia. In those areas, and actually Acapulco for some people has been used as a difficult exposure site. The 1130 never performed well in those exterior sites, so we were sort of wondering why. So we did you can see a little test up here, a setup where we simulate rain. So we just run water across the coating. We did pH 4 and 7, and the reason we did 2 pHs is just to simulate acid rain at pH 4, and then we did neutral rain for places that don't get acidic rain to see if there's a difference. Turns out there wasn't a difference, which surprised me, but okay. But what we did see was that when you introduce the water test, the 1130 is weaker. So in this first test, we're going out about 1100 hours. And the one thing you can say is the 5400, which is the triazine, is definitely better. That does not migrate out at all. And this BTZRX is Chigard R455. BTZRX means a benzotriazole that's reactive, which was put into a polyurethane dispersion. And in those cases where there's very little migration, we see that the UVA retention is a fair amount better. But when you add the water rinse, which is what we see over on the right, you can see that the 1130 is starting to look quite a bit weaker. Now, we did some follow-up tests and some different systems. The top one here is an acrylic. And you can see in this particular one, we're tailing off on the 1130 is pretty bad, this green line. And then down below in the polyurethane dispersion, we're seeing the 1130 is quite a bit weaker. And the ones that don't hydrolyze or get extracted are really performing quite a bit better. Okay, so I'm going to switch gears now and talk a little bit about a new material, Chigard 5481. We've just started manufacturing of this material, and it's showing some pretty interesting performance. Basically, we've taken some fairly high performance UV absorbers and some HALs and another specific wood stabilizer and made an optimized mix that in our testing over wood works better than any of the control materials. And the thing that's kind of interesting about it is it allows you to do a good, better, best kind of formulation. So if you put it in at a half loading, you can still get better performance than the standard formulating practice. But at the half loading, then if cost is a big driver, then you can be more competitive. And, maybe even at lower loadings, depending on how you want to do your value compromises. But if you want to get really good performance, something substantially better that your demanding customers want, then you can do that by putting in a pretty full loading of the material, and you can really reduce the color shift quite a bit. Okay, and that was really for wood coatings, clears or stains direct onto wood where the sunlight can hit the wood. Okay, we're going to talk a little bit now about a polymerizable UV absorber. When I say polymerizable, I mean something that doesn't just react in, but can polymerize in, so it reacts twice, not just once. And really, it's helping you maintain your Beer's law performance, because there's several things that are problems in long-term performance of UV absorbers. One of them is, is the material permanent? So if you put it in your paint, does it react? Does it go away? Is it unstable? Well, benzotriazoles and triazenes are both pretty stable. Although if you go to a benzophenone or an oxanolate or a cyanoacrylate, those are not photopermanent. And so they'll go away, and then they will not be contributing to your absorbance. The molar absorptivity coefficient is just how much light that UV absorber can absorb. And really, this coefficient should be looked at over different wavelengths. If you want to cover a broad spectrum, you would use a benzotriazole. Benzotriazole goes all the way out to 380 nanometers. If you go out to 380 nanometers, then you're covering really essentially the whole UV absorption spectrum, which is good. If you go beyond 380, then it's colored. So then people don't like that because it introduces kind of a yellow or even red color if you go too far up. Molecular weight really is related to the migration or heat resistance. A really big molecule will not sublime out of your coating and go away. So big is better, but it also dilutes the good chromophore. So the really big molecular weight UV absorbers usually don't have as good a molar absorptivity as the smaller ones. So that's kind of a compromise consideration. Migration is one of the things that people don't think about enough. And the migration is a big deal. Something like 1130 migrates very quickly, especially with water, car wash, soap. And when it does that, it's no longer working for you because it's gone. The smaller molecules, Tinuvin 328 was used for decades. And the only reason that was kind of okay was people would put in a lot of it. So it had a good molar absorptivity coefficient. So when you loaded it up with 3%, you could afford to lose a percent a year and still get some performance. Although eventually at 5 years or so, it would go away. Heat resistance, especially if it's a baking enamel, but also you have to be a little bit worried, and this is really important in Mexico. You get some bright sunlight. A car in Cleveland, Ohio, which is of course much further north than Mexico, gets all the way up. Well, Fahrenheit is 180 degrees Fahrenheit surface temperature. So you can hit 80 degrees C, 70, 80 degrees C fairly easily. And when you do that, you can boil a UV absorber out if it's not a big molecule or if it's not reacted into the film. And that's where our ChiGuard R455 really helps a lot. You can see those two hydroxyls, and they're connected to the benzotriazole UV absorber. So this is the broad spectrum UV absorber that absorbs a lot of light virtually all the UV light that comes down to ground level on the Earth. And then these hydroxyls can react into a melamine, an isocyanate. It could be a silane, anything that reacts with a hydroxyl. These can react in. And since it's a diol, it can react twice. So you can almost think of this as being a reactive diluent for a 2K iso that helps polymerize the 2K iso. And in fact, it's got enough hydroxyls and they react efficiently enough. We even recommend that a formulator take into account the hydroxyls that are on the UV absorber when you calculate your isocyanate to OH ratio in formulating your 2K iso. And so it really reacts in very well. We've done a lot of tests to show that with a good NCO to OH ratio, essentially 100% of it is reacted in, most of it twice polymerized. And so it's really a great way to get a UV absorber into a coating that now can't migrate. It's part of your polymer system. It's built right in. So it's really an excellent way to try and beat Mother Nature. Now, I said in a 2K iso, you don't have to have it cure in. You can actually polymerize it into a prepolymer. So a polyurethane dispersion and a waterborne coating, we've done that several times. It works great. It reacts in with a melamine coating. Usually that's done during cure. So whether you react it in ahead of time into your polymer network for your resins or have it cure in, either way, it reacts in really well and gives you an outstanding performance. Okay. In this particular slide, what we're trying to show is that if you want to load up a coating over a porous substrate, or a non-porous substrate, where you want to get a certain UV absorptivity to protect the material below, if you go back to Beer's law, you have to get that certain total concentration of material. Well, if you go at 2% or maybe even 3% of just a standard UV absorber, which is getting fairly concentrated in the coating, in order to get it thick enough to absorb all the light, you might have to put on 2 or even 3 layers of coating. So like on a deck coating or something like that, where you put on 3 layers, now you're putting on a lot of extra film and it's extra labor to really pile on that thick layer that absorbs all of the UV light. And what you can do now with the R455, you can concentrate it into your resin system at a higher level than you can do when you just add a free UV absorber. So for instance, if you were to add 10% Tinuvin 1130 or Chi-Guard 5530 into a coating, you would lose coating properties. Plus the material would migrate out, but you'd lose the properties of the film because it has too much free UV absorber floating around in there. Where if it's polymerized in, you can make it highly concentrated. And we went as high as 20%, but 10% is probably as high as people would normally go. You can make a really concentrated UV absorbing film that's thin and protects the substrate that is sensitive to light. So this is a great way to get a very concentrated UV absorbing film. Oops, my computer doesn't want to go down. Uh-oh. There we go. Okay. In this slide, what I'm trying to show is how you can make your pre-polymer with Chi-Guard R455. You'd need resin capabilities to do this, which I'm not sure how many of the people on this webinar have that, but you probably have access to it through one of your suppliers if you can't do it yourself. You can take an isocyanate. Very common one is HDI, hexamethylene disocyanate, either the monomer or the trimer of that. IPDI is often used. There's a variety of aliphatic isocyanates that make good sense. Actually works a little bit with aromatics too, but that gets tricky. The OHs here react with the isocyanate and gives you a urethane. Now, typically, you have other diols that you would use. They could be small, like neopentylglycol, or they could even be a hydroxyl prepolymer. For instance, a short chain polyester could be used. So there's a lot of different things that could be used as your supplementary diol. And then to make it water dispersible, one of the most common ways to do that is with dimethylol propionic acid. Basically, these hydroxyls will react with your isocyanate to form some urethane linkages. And then this acid group is what helps you emulsify it into your waterborne coating. It needs to be neutralized with an amine, dimethylethanolamine or disopropanolamine or triethylamine. There's a lot of amines you can use that will neutralize this in order to make the salt that allows you to make a very stable dispersion. In this case, they're using, I guess it's triethylamine. You need to disperse it in, so high-speed dispersion in order to make the particles the most consistent particle size. And then typically there'll be a co-solvent in here. Acetone is very volatile. Methylethyl ketone is sometimes used, and you just strip that off. And then you have a polymer now, a urethane polymer that's dispersed in water that has your UV absorber built right into it. And you can see here, they look fine. Actually, the real panels looked even better than this picture, but it disperses in and forms a really good film. And here, this is the QUV exposure. It shows how good this polyurethane dispersion with 5% polymerized in is. And that's comparing it to ones where we put on multiple layers with 1130. In this case, it comes out to the equivalent of 6% UVA. And we're still better with only 5% of the R455. And that's presumably because of the loss, the migration of the 1130. And if this was done with a car wash soap test or a rain test, I think we'd see a much bigger difference. We'd see that the 1130 goes away even quicker. Okay, we did some experiments here, which are kind of interesting with color. We want to compare some of these materials. There's some interesting considerations. The R455 is a benzotriazole. As I said, that has the broad spectrum. The Chi-Guard 5400, it doesn't migrate very much either. And it's got that hydroxyl that can react once. It's secondary, so it's not quite as efficient. This polymerizes in, where this can graft in a little bit. The 1130, this fraction of the 1130 mix can graft in, it doesn't polymerize in. But in a way that doesn't matter because this linkage here is weak and can break down, so it's not so great that reacts in. Just like this linkage here breaks, and then the 1130 goes away. And the 5582, it's a smaller benzotriazole, so it's not as permanent as some of the big ones, but it's a pretty good molecule. But it does not react in. So in a really difficult, stressful situation, we wouldn't expect this to be as good as the R455, which polymerizes into your system. Okay. So in this test, we did a red, and we picked the red on purpose because there's some automotive pigments that are a little bit more sensitive to to color shift than others. You don't have to go out quite as far. And of course, some colors won't shift. Black, that black is black and white is white. Those generally don't shift in color very much. And some of the blues are pretty stable as well. So we picked the red so that we could actually see the differences and see the impact of the UV absorber in a more pronounced way. So it's a tougher test. We looked at the 5400 triazine, the 1130, or 5530, if you will, 5582, and the R455. In this particular case, instead of water, we did an alcohol extraction, isopropanol, which is actually sometimes used. Some people clean their cars or other things, clean bugs off with isopropanol, for instance. Not quite as tough as actually the rain test, but I think it works quicker. At least in the lab, it's easier to do. And here's the results. We start off with our red, and this red is actually a mixture of the F3RK red pigment with titanium dioxide, which is really just to give it some good hiding and a consistent color to look at. And you can see down below, the R455 is clearly the best for color retention. And you might wonder why the 5400 isn't better. It's kind of middle of the pack. It's marginal. It's clearly better than nothing, which is the blank over here. And the reason for that is it doesn't protect you out at 360, 370 nanometers. So this is a case for this particular pigment where having the benzotriazole is an advantage. It gives you that broader protection. So in summary, we've got some improvements, especially for waterborne coatings. The WB series materials allows the formulator to use more concentrated additive and to get away from 1130 and 5530 into a more durable mix of absorbers, whether it's the 5400 triazine or the 5582 benzotriazole. So really good options for waterborne coatings. And the 5481, if you've got a clear or stain for exterior wood, it allows you to get to better color control than you otherwise would have. So for high performance needs, that's an excellent option you should look at. And then the polymerizable. Again, that's a way to take performance to the next higher level, especially in situations where they want 4, 5, 6, 7, maybe even 10-year type performance, or in harsh conditions. That's a very good way to go. And this final slide is kind of interesting. We pursue difference. And basically, that's just Tritech's way of saying we keep trying to innovate. We do have some Me Too products where we've copied some of the industry materials, but I think we've shown today, especially, that we're trying to work for you to make more materials that can do things that you need, and hopefully you'll agree. I'm going to move back. That's the end of my presentation. I'm going to leave one of my favorites. I'm going to leave this slide up because it shows the 3 waterborne. Okay, well, thank you for your attention. And if you've got some questions, I can try and answer them now, or we can do that through email.
Pues, gracias a todos. Ahorita yo creo que es momento, si tienen alguna duda, pueden escribirla en el chat. Ahorita vamos a empezar a leer las que ya estaban. O si gustan preguntarle directamente sin ningún problema.
Gracias, Alberto. Vamos a comenzar con el tiempo de preguntas y respuestas. Como bien lo menciona Alberto, Eric, si tienen alguna duda, por favor escríbanla en el chat, ya sea en inglés o en español. La vamos a a compartir con el ponente y la presentación se las vamos a estar mandando también, si quieren escribir su correo en el chat para que les enviemos la presentación. Entonces, si hay alguna duda, por favor, vayan escribiéndola en el chat. Y pues bueno, adelante, Alberto.
Con la primera pregunta.
Sí.
De acuerdo, Dani, gracias. Sí tenemos una pregunta de Flor Consuelo de Estal. Dr. Mauer, we are going to start with the questioning. So there's a question about does the quality or the particle size of the DMPA affects the prepolymer stability?
Okay. Yeah, that's a good question. And yes, when you are making the polyurethane dispersion, you need to use the right percentage of DMPA in order to get the optimum particle size. So basically, the polymer synthesis chemist would usually do several levels of dimethyl propionic acid in making his polymer, then disperse them, and would have a target particle size. Might be 400 nanometers or something like that. And usually if you go smaller, which is more DMPA, you can get a little more stable. Sometimes you don't want too small, so it's kind of a compromise. Usually 400 nanometers is kind of a target, but could be a little bigger, a little smaller. But yeah, and it would just be the standard methodology. There's nothing really different when you have the R455. It's just a particular monomer.
Thank you. Flor, vamos a darle respuesta a tu pregunta. Efectivamente, sí hay una influencia directa entre la cantidad que vayas a utilizar de tu DMPA y efectivamente cuando estamos trabajando de tamaños de partícula más pequeños vas a tener tú un prepolímero más estable y va a ir en función de lo que tú quieras obtener, va a ser la dosis que vas a tener que utilizar de este producto en combinación con el Chai-Ward, para que tu producto tenga la distribución adecuada y también pues va a tener en función de del ácido que ocupes, va también a tener cierta estabilidad, ¿no? Entonces vas a tener que estar jugando con la concentración para que tú puedas ir viendo cómo se va comportando esta dispersión.
Ayuda a preguntar la que digo yo.
Sí.
¿Cuál? Dr. Mauer, there is some specific UV absorber for waterborne exterior epoxy coatings.
Actually, for the waterborne epoxy, probably the broader spectrum is better. So that would be the Chai-Guard 5582 WB. Because this will give you protection out to 380 nanometers, which is a little better. Oh, you know what? I can actually, I think I have a hidden slide in here. Not sure. Yes, I do here. Okay, can I make this, how do I make this bigger? Can you see this slide?
Yeah.
I think you, okay. The reason I said the 5582 WB is because I guess the green line gets hidden. It's out here, it's under there, it's the green line. It covers out here. Okay, a little further towards the visible. So it gives you that little bit of extra protection. If you were to only use like the 5400. The 5400 would do a great job down here, but then it wouldn't do as well in here. You can see how there's this difference. Now you can use a blend of 5400 and 5582. That's a pretty good idea also. And, you know, with those epoxies, they're also extremely sensitive to HALs. So, so you'd want to make sure that you had a good amount of HALs in there. Whoops. There we go. As well, it's with the 101 WB that will go after the radicals that are formed and give you some extra protection. A lot of protection, actually. The house is more important even than the UV absorber.
José Greco, comenta el doctor Mauer que efectivamente sí hay aditivos que te pudieran servir en combinación para dar la extra protección a los HALs. En sistemas epóxicos sería el 5400 en combinación con el 5582, debido a que al tener una longitud de onda en el rango visible, sí sabemos que los epóxicos tienden a tener esa sensibilidad al ataque de la luz. Entonces tendríamos que ampliar el rango de esta longitud de onda, cubriéndolo desde los 400 nanómetros hasta los 360. Es por eso la recomendación en la combinación de ambos productos. Now, which mixture do you recommend for a baking coating to 500F Fahrenheit?
Woo! Okay. Yeah. Is this a waterborne coating or a solvent-borne coating or powder?
Recio, ¿nos podrías dar mayor información si es base agua, base solvente? ¿Qué tipo de sistema es, por favor?
O es en polvo.
Waterborne.
Waterborne, doctor.
Waterborne. Okay. Okay, at 500F, you don't have a lot of choices. I guess in that case, I would not use 5582 WB. I think the 101 WB would be your choice for house, because it's a little bigger than, for instance, the old 292 type option, if you could emulsify that in. But so definitely the 101 WB for your house. Now, for the UV absorber, the best thing to do would be to use this goes back to your synthesis people. You'd have to have your synthesis people incorporate the R455 into your resin. And that way it can't boil out. It's polymerized in. Now, otherwise, the best one is the least volatile would be the 5400 WB. But at 500, you're going to lose some. You know, even this one, which is of the free UV absorbers, it's the least volatile. But 500 is really, really high. How much time at 500?
500 Fahrenheit degrees.
¿Cuánto tiempo? Recio?
Recio, ¿cuánto tiempo?
10 minutes.
10 minutes.
10 minutes.
10 minutes.
Okay. Yeah, the 5400 might stay in the film enough. You're going to lose some, but it's possible. The best way is definitely to try and get R455 polymerized into your resin beforehand. Would be the best.
Okay.
Next best would be you could try 5400.
Ok. Recio, comenta el doctor Mauer que deberías de primero hacer un prepolímero con tu resina utilizando el R455 y si fuera necesario pudieras adicionar como aditivo el 5400, debido a que al ser un material sensible a la temperatura, garanticemos que la película tenga la suficiente solidez y resistencia.
You know, one thing you could
Dr.
do.
Mauer,
Yeah, go ahead.
thank you. Could you please explain again how does your product works for porous surfaces?
Yeah.
Please.
You know, the concept here is really just where's R45? In this case, if we make our polymer with R455, you can put in 10%, in this particular case, we did 10% of R455 into the polyurethane dispersion. So that's very concentrated in UV absorber. And these little dots are the green dots are supposed to represent R455 molecules in the polymer system. And the idea is that you can make the UV absorber more concentrated in the film so that at a thin film, you can absorb more light. If you were to try and put tin-UV 1130 in at 10%, or since that's got a higher molecular weight, you might have to go to 15%, then you would hurt the film properties and it wouldn't be a good coating. Even though you might get very concentrated then in UV absorber, your film wouldn't be good. So what you would have to do is put it in at 3%, but then put on several layers in order to get as much UV absorbing capability out of your film. So the concept here is that this substrate is sensitive to UV light, and you want to get UV protection above it. And this just gives you a way to get a lot more concentrated UV absorber into your film. And so you can use less coating. So for instance, in this case, you might have 1 mil of coating in order to absorb all the light, maybe 2 mils. And here you might need 2 or even 3 times as much coating to absorb all the light. Does that help?
Sí. Oscar, nos explica el doctor Mauer en las imágenes que tú puedes observar, donde dice en color azul, porous substrate, estamos hablando de que ese es el sustrato donde va aplicada tu película. Y, por ejemplo, en la imagen de abajo, donde tú observas los puntos verdes, ahí estás teniendo la mayor concentración del aditivo 455 en tu resina. Lo ideal es que la imagen verde sea nuestra guía porque ahí vas a tener una mayor protección a la resistencia a la luz UV. Mientras mayor concentración del aditivo tengas, vas a utilizar menos cantidad de tu producto y lo vas a tener más protegido. Por ejemplo, en las imágenes de arriba donde tiene los puntos amarillos, donde dice monocoat, tienes menos cantidad de este aditivo y estás permitiendo la mayor cantidad de paso de la luz UV y ahí no estás garantizando que tu producto se proteja. Del lado derecho, donde hay más puntos amarillos todavía, estás dándole cierta protección, pero lo ideal sería trabajar en concentraciones de 3% de este aditivo como un comienzo para que puedas proteger tus productos. Y que el sustrato, al ser poroso, tiende a absorber la luz. Entonces sí lo estás protegiendo a través de una película que ya va a estar aditivada. Y puede ser aplicable para varios tipos de sistemas. En este caso, en el ejemplo, mencionan, pueden ser productos para madera, papel, algunos plásticos o metales, incluso vidrio. Dr. Mauer, please, there are some UV stabilizers that contains benzotriazole, and they are forming some complexes from cobalt and copper. So does they affect some material properties. Do you know if these Chi-Guard additives forms these kind of complexes?
Yeah, that's a good question. In general, and color is the problem I think that you're probably referring to, or at least that's the one I'm familiar with, is benzotriazole with cobalt and some other metals can form color bodies, which gets in the way of what you're trying to do with the coating. And the way around that is to use the triazine, as in where? Oops, where is it? There we go. I think that the part of the molecule that's causing the problem is the chromophore, the benzotriazole itself. And I don't think it matters which one you use. So I think our 5582 would be a problem. I think 1130 would be a problem. So whenever you have those metals, any of the benzotriazoles will be a problem. But the triazine does not form the metal complex that gives color. So this would be a good way to go. The problem, the shortcoming of it is you will lose a little bit of the protection that you get from a benzotriazole out at that, I guess I can pull that back up, out around 360, 370 nanometers, which in a lot of cases that doesn't matter, but in some cases it does matter. So you would be using this blue curve of absorptivity. You'd be a little better down in the high energy part of the spectrum down here. You can see the 5400 is better, but you can see out here it's not as good. So that's one of the problems you'd have if you've got those metals in there to contend with, is you probably will have to give up protection out here. Does that help?
Thank you. Tengo la pregunta.
Carlos Flores.
Carlos, nos explica el doctor que hay algunos de los productos.
Ya lo entendí. No he visto traducción.
De acuerdo.
Así que ya parece que solamente hay una pregunta.
There's the last question.
What UV absorber do you recommend to achieve 4,000 hours in Q-zone for a pure Waterborne system?
You know, the one that goes the best in a waterborne is actually, it depends on what you're looking. There's some details in there that are hard. You know, for instance, depending on if there's certain colors that you need to protect, or a certain susceptibility to cracking or delamination, depending on what the substrate is, that could change what the optimum approach is. A great starting point is actually using a mixture of 50-50 of the 5582 and the 5400 WB. Is a really good UV absorbing mixture. And of course, you always want to make sure you have the house in there as well. So if I was to tell someone where to start on a waterborne coating, I would say 1%. And when I say 1%, this is difficult in different language. Hopefully this can translate well. But 1% of solids on solids. So these are 30% solids. Well, and if your paint is 30% solids also, then it would be, you know, just 1% of 5582, 1% of 101 WB, and 1% of Chi-Guard 5400 WB. So your additives would be a total of 3% using the 1 and 1 and 1 mix. Would be an excellent first choice.
Thank you. Marcos, comenta el doctor Mauer que puedes utilizar estos 3 aditivos y como fórmula de arranque, digamos así, guía, podrías utilizar el 1% de cada uno de ellos y obviamente va a ir en función de los sólidos que tenga tu sistema. Vas a poder hacer un ajuste incluso hacia abajo o hasta máximo el 3%. Por el momento son todas las preguntas.
A ver más. There's another one. Can you explain again why do I need more protection between 340 to 380 nanometers when I am using copper and cobalt?
Well, no, the only reason I mentioned that was with the cobalt, in general, you get, I think, the reason they didn't want to use the benzotriazole was it got colored. Is that correct?
The color?
Yeah, don't you get a bad color when you use benzotriazole with cobalt?
Yes.
Okay, so with triazine, you don't get the color. And I was just trying to say that if you only use triazine, which you probably have to do because you don't want color, then you just won't have quite as good protection out at 370 nanometers, which might not be a problem. Or it might be, depending on your pigmentation or substrate, you know.
Dr. George, on behalf of the RODAJ team, we want to thank your contribution and share with us your wide knowledge. Be sure that we'll make a big effort to clarify all the doubts that could arise and share this information to our customers. And we'll be in touch. And again, thank you, George.
Okay, well, thank you for listening and your attention.
There's one more question. Can we combine inorganic fillers with additives to improve UV resistance?
Excuse me, again?
Can we combine inorganic fillers with these additives to improve UV resistance?
Yeah. In fact, depending on what your tolerance is for color, iron oxide is sometimes used, or carbon black. So I know in automotive, very often in a primer surfacer, if you wanted to protect an E-coat, you would use iron oxide or carbon black in your primer surfacer to get extra UV protection. So yeah, they can work, but of course, they bring in color. So.
That's it. Thank you. Pues, si no hay nada más, muchas gracias a todos los que estuvieron aquí hasta el final. Vamos a estar compartiendo la presentación a los correos que nos compartieron. Estamos a sus órdenes. Bueno, ya en la propaganda que se mandó viene también nuestros teléfonos y el correo donde nos pueden contactar. Y pues, muchas gracias. Buen día.
Gracias,
Muchas
doctor.
gracias a
Thank you,
todos.
George.
Thank you, George.
Okay,
Thank you for your
thank
time,
you.
Jay. Thank you.
Están los
Adelante,
correos
adelante.
aquí, están los correos en pantalla. Si alguien tiene alguna duda adicional, si alguien necesita que le compartamos la presentación o cualquier detalle que haya surgido derivado de esta presentación, por favor pueden contactar a estos correos y con todo gusto les vamos a estar dando seguimiento.
Okay. Thank you, George. Thank you, everybody.
Thank you, George.
Bye-bye.
Hasta luego.
Hello.
Video y...
Gracias, Dani, igualmente por todo. Gracias, Dani.
Alberto, Eric, Tania, muchas gracias.
Tania, Monse.
Monse, creo que también está por ahí.
Fabián, Moni,
Ujú.
aquí el jefe es el que está sentado ahí en la cabeza de la mesa, es Antonio González, Araceli, solo si estás conociendo al equipo.
A todos, muchas gracias. Digo, no tengo el gusto, creo, de conocer a todos, pero ojalá algún día podamos coincidir.
Es que la vez de la fiesta del aniversario que te cotizaste, Dani.
Ah, sí.
No,
Oye, te cotizaste, Dani, me dijo Roberto.
no, es que Roberto Roberto me había invitado y a la mera hora me dijo, ¿qué crees que no voy a poder? Y pues ya yo me sentí así como que dije, híjole, de por sí soy el invitado del invitado y pues como que no lo sé.
Estás con confianza.
¿No has hablado? ¿Tienes mi celular?
Ah, bueno, sí, eso sí.
La próxima.
Para el siguiente año, pues nos vemos
Sí.
en el
Es más, para la próxima nada más te invitamos a ti.
Ok, no, si no adelantamos esa próxima y luego yo los invito o algo así.
Dale, pues.
Gracias.
Pues muy
Muy
bien,
Muchas
muchísimas
gracias.
gracias a ustedes por ahí, Monse, muchas gracias. Bueno, gracias Alberto, Eric,
Sí.
gracias a todos, gracias Dani, que tengan buen día.